Hello students and good morning. So now I am doing class 12. The topic is functions. So in the last online class also we were doing functions, and in that online class we did some problems on functions from the book Senior Secondary School Mathematics for Class 12 by R.S. Agarwal. So today also we will do more problems on this chapter functions from the same book Senior Secondary School Mathematics for Class 12 by R.S. Agarwal, right? So in the last online class we did question number 9 from the exercise, that is exercise 2A, that is page number RF 30. So in the last online class we did up to 9 number 1 and number 2. So today we'll do this question number 10. So that the function number 1, if the function f such that n to n is the set of natural numbers. You know, this first n is the domain and the second n is known as the codomain. It is defined as f of x is equal to x cube. You have to prove that this function is 1, 1 in 2. So first of all you have to prove that this function is 1, 1. So what is the meaning of 1, 1 function? That is, for each distinct element in the domain n, it should have distinct image in the codomain n. That is, each distinct element in the domain n should have distinct image in the codomain n. That is known as 1, 1 function. So you know the mathematical proof. How can you do the mathematical proof for f to be 1, 1 function? Okay. Then you have to prove that it is into function. What is meant by into function? There are some elements in the codomain n which do not have. There are some elements in n, that is n codomain, which do not have pre-image in the domain n. Is that clear? That is your into function, right? So now here given is f such that n is the set of natural number n to n, defined as f of x is equal to x cube. So now in order to prove that f is 1, 1, so we have f of x1 is equal to f of x2, then we should prove that x1 is equal to x2, right? Which implies that, or we have f of x1 is equal to f of x2 for all x1 comma x2 belong to the set of this natural number, that is your domain n, right? So which implies that if f of x is equal to x cube, what is the value for f of x1? This is your x1 cube is equal to, what is f of x2 now? Instead of x you put x2, this is your x2 cube, which implies that if x1 cube is equal to x2 cube, you can write x1 is equal to x2. That is, the function f is 1, 1. Therefore the function f is 1, 1. Is that clear to all of you? So we have proved that the function f is 1, 1. Now prove that the function f is into function. So for this, let us assume that let y is equal to x cube. Okay. So what is the value for x now? What is x is equal to? It is cube root of y. So x, what is the value for x? Express x in terms of y. That is, x is equal to cube root of y. So if you put, if y is equal to 2, you know that 2 is a natural number. Suppose this y belongs to the codomain n. Suppose this y belongs to the codomain n. Okay. So you know that 2 is a natural number which belongs to the codomain n. Okay. So if you put y is equal to 2, what is the value for x? That is your cube root of 2, which is not a natural number. That means x is equal to cube root of 2, that is this cube root of 2 does not belong to this domain n, because this cube root of 2 is not a natural number. Is that clear? Which does not belong to n. So is that clear? That means if y is equal to 2, then x is equal to, it is not a natural number. That means 2 belongs to the that is 2 belongs to y, that is 2 belongs to this codomain n. It does not have any pre-image in the domain n. So therefore 2 belongs to this n codomain does not have pre-image in the domain n. Is that clear? So here n is the set of natural numbers. Both this n is the set of natural numbers. Okay. So therefore f is into function. So hence the function f is f is 1 1 into. So we have proved it. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is 10 number 2. You have to prove that the function f such that z to z. You know that this z is the set of integers. It may be positive integers, it may be negative integers including 0. Both these z are the set of integers defined as f of x is equal to x cube. You have to prove that this function is 1 1 into. Now you know the definition of 1 1 function, many one function, into function and onto function. Now let us prove that this function is 1 1 into. Okay. Now here given is f such that z to z defined as f of x is equal to x cube. Now you know the method how to prove 1 1 function, isn't it? So now we have to prove that if f of x1 is equal to f of x2, then it should imply x1 is equal to x2 for 1 1 function. So we have f of x1 is equal to f of x2, which implies that if you put x1 instead of x, what is the value for f of x1 is equal to x1 cube. This is your x1 cube is equal to, what is f of x2? Instead of x, you put x2. So f of x2 is equal to x2 cube, which implies that if powers are equal, bases must be equal. So x1 is equal to x2. Therefore, f is what? 1 1 function. Therefore, f is 1 1 function. Is that clear to all of you? So now let us prove that it is an into function. This function f is an into function. So here also let us assume let y is equal to x cube. So let us get the value for x. So what is x is equal to? It will be cube root of y, isn't it? Actually it is y to the power 1/3. It is just like cross multiplication in the power. So what is the value for x? X is equal to y to the power 1/3. So y to the power 1/3 means it is cube root of y. Okay. So again, if you put if y is equal to 2, you know that 2 is an integer. You know that y is equal to 2. 2 is an integer. That means this 2 belongs to this z codomain. So what is the value for x now? So x is equal to cube root of 2. Now this x belongs to z, but is cube root of 2 is an integer. No, cube root of 2 is not an integer. It is not an integer. It is not a whole number. So it does not belong to Z. That is your domain. That is your domain. Is that clear? So therefore here we see that 2 belongs to the Z integer. That is your codomain. Codomain. So 2 belongs to Z codomain. It does not have that is, if you put y is equal to x is equal to cube root of 2 is not an integer. That is, it does not belong to the Z domain. So this 2 does not have any pre-image in the domain Z. Okay. So therefore you know that 2 belongs to Z codomain. So it does not have pre-image. It does not have pre-image in domain Z. In domain Z. So I think I've understood it. So that means therefore f is into function. Therefore f is into function. So hence the given function, that is f, hence the function f is 1 1 into. So it is proved. So I think I've understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 15. Which of the following relations are functions? Question mark. Give reasons. And in case of a function, you have to find out its domain and range. So here the question given was, number 1 is, which of the following relations are functions? यहाँ कतिवटा रिलेसन्सहरु दिएको छ त त्यो रिलेसन्सहरु कुन कुन फंक्शन्स हो होइन त्यो हामीले चेक गर्नुपर्छ. And if it is a function, you have to give the reason. If it is not a function, you have to give the reason. So in case of a function, you have to find out its domain and range of the function. Okay. So number 1 is f is equal to, so here it is given in terms of ordered pair, -1, 2, then it is 1, 8, then 2, 11, 2, 11, 3, 14, right? So this is the given relations. So is this relation a function? You have to check it. Okay. So this is the first element. This is given, this relation or function is given in terms of ordered pair. Okay. Now suppose this is your A and here is the first element, that is -1, 1, 2, 3. -1, 1, 2, 3. Next one, this is your B. This is your B, and B is the set of elements 2, 2, 8, 11, 14, right? So in this case, -1, 2 is there. That means -1 is related to 2. This -1 is related to 2. 1 is related to 8. 2 is related with 11 and 3 is related with 14. That means यहाँ जुन चाहिँ सेटमा एलिमेन्ट्सहरु छन् कुनै पनि छोडिएन, यहाँ सबको इमेज चाहिँ केमा छ, B मा छ. Is that clear? So -1, 1, 2 and 3, they have a unique image. They have unique image in the set B. So it is a function. So I think I've understood it. So every elements in the set A has unique image in the set B. So it is a function. Is that clear? So this is a function. So the relation f is a function. Is a function because because every element in the set A has unique image in the set B. Is that clear? So it is a function. So we have given the reason also why is it a function. Okay, so since it is a function, you have to find out its domain and range. As you know that these first elements, this is the domain, this set A is the domain, and this set B is the range. Is that clear? That is, the second elements of this f denotes the range of the function f. So therefore, domain of f is equal to, what is domain of f here? Minus 1, comma 1, comma 2, comma 3. All are related with the elements of set B. So this is the range of f. So what is range of f now? So range of f is equal to, what is range of f? 2, 8, 11, 14. So these are the answer. That is the range of f is 2, 8, 11, 14. And what is the domain of the function f? That is minus 1, 1, 2, 3. So I think you have understood it. So you can copy it. Now we'll do the next question, that is number 2. So now we'll do the next question, that is 15 number 2. You have to check whether this given G relation is a function or not. If G is a function, you have to give the reason for the function. For G to be the function, you have to give the reason why is it a function. If G is not a function, also you have to give the reason that why G is not a function. Okay. So let us consider two sets. That is your set A and this is your set B, right? So set A has the elements 1, this is 1, 4, 9, 16, right? And B has the elements 1, minus 1, that is 2, 3, and this is 4. Okay. So 1 is related with 1, 1 is related with 1, again 1 is related with minus 1, again 1 is related with minus 1, 4 is related with 2, 9 is related with 3, and 16 is related with 4. So is it a function? I already told you that what is the definition of function? The definition of the function is that every element in the set A must have unique element in the set B. But in this case, this element 1 in the set A has two elements in the set B, that is 1 and minus 1. It is not unique. So it is not a function. Is that clear? किनभने यहाँ जुन चाहिँ 1 belongs to the set A, this 1 belongs to the set A, and here 1 has two images in set B. 1 has two images in set B. It is not unique, so it is not a function. Okay. G is not a function. G is not a function because 1 belongs to A has two images. 1 and minus 1, two images 1 and minus 1 that belong to set B. So it is not a function. Is that clear to all of you? You 1 ko duita image bhante यहाँ 1 र minus 1. The definition of the function ले चाहिँ के भन्छ भन्दाखेरि each and every element in the set A must have a unique image. Must have unique image in the set B. एउटा इमेज मात्र हुनुपर्छ. त मोर देन वान इमेजेस भयो भने चाहिँ त्यो फंक्सन हुँदैन. सो G is not a function because 1 belongs to the set A has two images 1 and -1 that belong to the set B. So G is not a function. Is that clear? So you can copy it. Now we'll do the next question. So now next we will do question number 15, number 3. Which of the following relations are functions? You have to give reasons, and in case of function you have to write down domain and range of the function. So now here the function is given as h. Is h a function or not? You have to check it. So you have to give the reason if it is a function. Again you have to give the reasons if it is not a function. Okay, so let us check it whether it is a function or not. Okay, so this is your set A, this is your set B, this is set A, this is set B. These first elements belong to the set A, that is A, B, C, D. Now this is B, this is only B, C. B, then comes C, again B is here, again C is here. Okay, now A is related with B, A is related with B. Again B is related with C, B is related with C. Again C is related with B. A is related with B, sorry, B is related with C. Sorry, this one is wrong. So in this case, A comma B is there. A is related with B. B comma C is there. B is related with what? C. Is that clear? Next, C is related with B. C is related with B. And D is related with C. D is related with C. That is, A is related with B, B is related with C, C is related with B, and D is related with C. So is it a function? That is, every element in the set A has unique image in the set B. तो सबै एलिमेन्ट को नै यहाँ जति पनि एलिमेन्टहरु छ सेट A मा सबैको इमेज केमा छ B मा छ, and it is also unique, so it is a function. Okay, so here you can write age is a function. Age is a function because every element in A has unique image in B. Okay, so this is a function. Okay, now what is the domain and range of the function h? So domain of h is equal to, what is domain of h? That is, domain of h is the set of A. Set of A has the elements A comma B comma C comma D, A comma B comma C comma D. That is your domain of h. Now what is range of h now here? So range of h here is the set of B, that is B comma C. That is B comma C is the range of h. So I think you have understood it. So you can copy it. Now we'll do the next question now. So now let's do question number 14. Find the domain and range of the function if such that this is real to real number. R is the set of real number. This R is also the set of real number. First R is known as the domain and the second R is known as the codomain. So this function is defined as f of x is equal to x square plus 1. Okay. Now here x is a real number. This x belongs to the domain R, and this f of x belongs to the range, belongs to the codomain R. This R, यो R ले चाहिँ के बुझाउँछ? Set of real numbers. And this small x belongs to the domain R, and this f of x belongs to the codomain R. Is that clear now? So what is meant by domain and range? How to get domain and range? Okay. Suppose if you have y is equal to f of x. Domain means those real values of x for which f of x is defined. Is that clear? Domain means you have to find out those values of x for which f of x or y is defined. Is that clear to all of you? Domain. यहाँ जुन चाहिँ तिमीलाई domain of the function निकाल्नु भन्दैछ, you have to get those real values of x for which y is defined or f of x is defined. Is that clear? Next, you have to find out the range of the function. Range of the function चाहिँ हामी कसरी निकाल्छौं? त पहिले हामी के गर्छौं? X is expressed in terms of y. त यहाँ range भनेको चाहिँ f of x को भ्यालुजहरु निकाल्नु पर्यो. You have to get those values of f of x for which x is defined. You have to get those values of f of x or y for which x is defined in this case. Is that clear? So let us find it now. Now here, given here is f of x is equal to x square plus 1. So for every real values of x, this f of x is defined, isn't it? For every real values of x, this f of x is defined. So what is the domain of the function f here? It is x belongs to the set of real numbers. That is your domain. Is that clear? X को जतिसुकै यहाँ real values हरु हाल. X को जतिसुकै real values हरु हाल, f of x के हुन्छ? जहिले पनि define भइहाल्छ. ठीक छ? So now for x belongs to the set of real numbers, then f of x is also real. If x belongs to the set of real numbers, then f of x also belong to real number. So therefore the domain of the function is what is the domain of the function? X belongs to the set of all real numbers. So x belongs to the set of all real numbers. Set of all real numbers are defined out here. Okay, so this is the answer for the first part. That is, we have got the domain of the function. That is, those values of x for which f of x is defined is x belongs to the set of real numbers. Is that clear? Next, you have to get the range of the function. Range of the function means you have to find out those values of x for which x is defined. So let us assume, let y is equal to f of x is equal to x square plus 1. Right? So now, which implies that y is equal to x square plus 1. So let us express x in terms of y. So what is x square is equal to? This is your y minus 1. You know that. X square is equal to y minus 1, which implies that x is equal to root over y minus 1. Is that clear? Now, for x to be defined, this y minus 1 को value के भयो भने चाहिँ x is defined. This is within a square root. If you get within a square root negative number, it is undefined. So x is undefined if y minus 1 is less than 0. But x is defined when y minus 1 greater than or equal to 0. Isn't it? So for x to be defined, y minus 1 should be greater than or equal to 0. I think you have understood it. For x to be defined, y minus 1 should be greater than or equal to 0. Okay? Only square root of non-zero quantity is defined. Only square root of non-zero quantity. Non-zero. That is square root of 0 is defined. Square root of non-zero isma. Non-zero means 0 into 0 into because square root of 0 is 0. That is your defined number, isn't it? Root over 0 is always 0, that is your defined number. But within square root, if you have negative number, it is undefined. Square root is the negative number, x ke huncha undefined bhayhalcha. So it should be greater than or equal to 0. So y minus 1 should be either 0 or it should be positive for x to be defined. Is that clear? So for x to be defined, y minus 1 should be greater than or equal to 0 or y greater than or equal to 1. Is that clear? So what is the range of the function? It is y greater than or equal to 1. Therefore, range of the function is y greater than or equal to 1. So this is the answer. So I think you have understood it. So what is the range of the function? Range of the function is y greater than or equal to 1. x को तिमीले जतिसुकै भ्यालु हाल, यो f of x को भ्यालु जहिले पनि के हुन्छ ग्रेटर देन or equal to 1 हुन्छै हुन्छ. यो कहिले पनि नेगेटिभ हुँदैन. यहाँ x नेगेटिभ हाल, x नेगेटिभ हाले पनि होल स्क्वायर लेख्दा पोजिटिभ क्वान्टिटी. सो f of x इज अ पोजिटिभ क्वान्टिटी. यो y को जग्गामा तिमीले f of x लेख्यो पनि हुन्छ, y लेख्दा पनि हुन्छ. ठीक छ? So what is the range of the function? It is y greater than or equal to 1. It is the set of real numbers. Range के भयो? Set of real numbers but y greater than or equal to 1. Okay? So this is the range of the function. So I think you have understood it. So you can copy it. So now we'll do the next question, that is question number 16. In this case also you have to find out the domain and range of the real function. Real function means defined function. Okay, that means x belongs to the set of real numbers, x belongs to the set of real numbers, and f of x also belongs to the set of real numbers. Okay, so it is defined by, the function is defined by f of x is equal to x square upon 1 plus x square. So for this function you have to find out the domain and range. Domain means you have to find out those set of values of x for which f of x is defined. You have to find out those set of real values of x for which f of x is defined, that is your domain. And for range you have to find out those values of f of x for which x is defined. Is that clear? And you have to also show that f is many one function. Okay, so let us find out the domain and range of the real function first. Okay, so here given is f of x is equal to x square divided by x square. So from the function itself we can see that all real values of x are defined here, isn't it? If you put any real values of x here, f of x is defined. If x is equal to 0, the value is 0. If you put x greater than 1, all real numbers, f of x will be defined. If x is negative, if x is less than 0, all real numbers are there, so f of x is always defined. Okay, so therefore f of x is defined if x belongs to the real number r, where r is the set of real numbers. So therefore what is the domain of the function? Domain of the function, therefore the domain of the function is x belongs to the set of real numbers. So I think you have understood it. Okay, now we have to get this is the answer for the first part, that is the domain of the function is x belongs to the set of real numbers. Okay, now we have to find out the range of the real numbers. That means you have to get those values of f of x for which x is defined. So let us assume let y is equal to f of x. Let y is equal to f of x is equal to x square upon 1 plus x square. Right? So next what will you do here? So let us equate, which implies that y is equal to x square upon 1 plus x square. So let us express x in terms of y. In order to get the range of the given function, let us express x in terms of y. Okay, So now let us do cross multiplication here. So it is x square is equal to y plus x square y. It is cross multiplied. Okay. So keep the terms containing x square on the left hand side. So which implies that x square minus x square y is equal to y. Which implies that x square is taken common, 1 minus y is equal to y. Which implies that x square is equal to y upon 1 minus y. Which implies that x is equal to root over y upon 1 minus y. So I think you have understood it. Okay, now for x to be defined within a square root, it should be defined quantity. Within a square root, it should be a defined quantity. Okay, so now in this case 1 minus y not equal to 0. If 1 minus y is equal to 0, if 1 minus y is 0, then something divided by 0 is undefined. That's why this 1 minus y should not be equal to 0. Or you can write minus y not equal to minus 1, minus minus gets cancels. That means y should not be equal to 1. So y should not be equal to 1. Is that clear now? So next, what is the condition for x to be defined within a square root? Within a square root, it should be greater than or equal to 0. Okay, for x to be defined, y upon minus y should be greater than or equal to 0. It may be is equal to 0, right? It may be is equal to 0. Y upon 1 minus y is equal to 0. That is root over 0. Root over 0 is a defined quantity. You know that. And this y upon 1 minus y should be always positive. किनभने स्क्वायर भित्र पोजिटिभ नम्बर भयो भने मात्र त्यो के हुन्छ, डिफाइन हुन्छ. अदरवाइज if it is root over negative number, so x is undefined. You should not have negative numbers here, right? So let us simplify it now. So let us multiply, let us make it positive quantity, 1 minus y whole square. Okay, so multiply and divide it by 1 minus y again. 1 minus y divided by 1 minus y whole square. So whatever may be the value for y here, 1 minus y whole square is a positive quantity. So we have made it a positive quantity. So now you can cross multiply it. So y into 1 minus y should be greater than or equal to 0, right? So suppose this is number 1. Now here यो जुन चाहिँ लेफ्ट साइड छ यो कति बेला 0 हुन्छ. You left hand side y, you have to find out those values of y for which this condition 1 is satisfied. Okay, what are those values of y for which this condition 1, that is greater than or equal to 0, is satisfied? Now we have to find out those values of y for which this condition number 1 is satisfied. Your condition 1 is y into 1 minus y greater than or equal to 0. Okay, त अब हामी के गर्नु पर्छ, यो लेफ्ट ह्यान्ड साइड कति बेला 0 हुन्छ त्यो हेरौँ पहिला. एउटा y is equal to 0 हाल्दा फेरि 0 into any number is always 0, and if you put y is equal to 1, that is also 0, हैन. त पहिला हामी के हेर्दै छौ, what are those values of y for which this expression is always 0. So if y is equal to 0 and y is equal to 1, then condition 1 is satisfied, isn't it? Then condition 1 is satisfied because you know that if you put y is equal to 0, 0 into any number is always 0, which is equal to 0, that is satisfied. Again, if you put y is equal to 1, 1 minus 1 is 0, 0 into any number is always 0, that is also 0 is equal to 0. This condition 1 is satisfied. So I think you have understood it. Okay, now let us draw a number line here. Suppose this is a number line. So when y is equal to 0 and y is equal to 1, so let us plot this point here. on this number line. So y is equal to 0 is this one, and y is equal to 1 is this one, right? So on the right of y is equal to 1, all the values of y are greater than 1. You know that, isn't it? On the left, on the right of y is equal to 1, all the values of y are greater than 1. And on the left of y is equal to 0, all the values of y are less than 0, right? And in between this 0 and 1, that is, the values of y lies between 0 and 1. That is 0 less than y less than 1. It is 0 less than y less than 1. That means y lies within 0 and 1. Is that clear? So next. So let us check this condition 1. Whether this condition 1 is satisfied or not when y greater than 1. So let us check for y greater than 1, is condition 1 satisfied or not? Okay. So if y is greater than 1, then if y is greater than 1, then what can we say about y? Y is positive. If y is greater than 1, y is positive. That means then y is greater than 0. And what's about 1 minus y? What's about 1 minus y? Is 1 minus y positive or negative? If y is greater than 1, is 1 minus y positive or negative? Y greater than 1 means you can put 2 there. 1 minus 2 is negative. So it is negative quantity, less than 0. Right? So what is the sign of the product? Therefore, y into 1 minus y, and this is positive and this is negative. So positive and negative is negative. That is your less than 0. Is that clear? So is condition 1 satisfied? No. It should be greater than 0, but we are getting here less than 0. So you can write here, if y greater than 1, then condition 1 is not satisfied. Then condition 1 is not satisfied. So I think you have understood it. Okay. So next, let us check whether this condition 1 is satisfied or not when y less than 0. Okay. So if y less than 0, comma, then. If this y less than 0, comma, then here it is y. Y is already negative out here. So y is less than 0. And what can we say about 1 minus y? Because there are two factors here, y and 1 minus y. And just now we have assumed y less than 0. If y is less than 0, what can we say about 1 minus y? Is it positive or negative? It is positive. Y less than 0 means you can put minus 1 there. So minus into minus plus 1, 1 plus 1 is 2, which is positive. That is your greater than 0. So what is the sign of the product? Therefore, y into 1 minus y, 1 is negative, 1 is positive. So what is negative into positive? It is negative. So here also, is condition 1 satisfied? No, it should be greater than 0, but here we are getting less than 0. Okay. So here you can write, if y less than 0, then condition 1 is not satisfied. Then condition 1 is not satisfied. So I think you have understood it. Okay. So next one is, now you have to check condition number 1, whether it is satisfied or not when 0 less than y less than 1. Okay. So if 0 less than y less than 1, comma, then first of all, what is the sign of this y? You have to check this condition number 1. What is the sign of y? Y is greater than 0, that is positive. Y is greater than 0, and what's about 1 minus y? What's about 1 minus y? So here y is less than 1. If y is less than 1, this y is less than 1. What is the sign of 1 minus y? It is positive. So y lies between 0 and 1 means 0.5. So you can check it here by putting y is equal to 0.5. So what is 1 minus 0.5? Is it positive or negative? it is positive, so it is greater than 0. Okay, so therefore y into 1 minus y, this is positive, this is also positive. Positive to positive is positive, that is greater than 0. Is condition 1 satisfied here? Yes, condition 1 is satisfied. So if 0 less than y less than 1, then condition 1 is satisfied. Then condition 1 is satisfied. So I think you have understood it. So now you have to find out those values of y for which x is defined, isn't it? You have to find out those values of y for which x is defined. Okay. So now in the previous step, we had if y is equal to 1. So actually the value for x was root over y upon 1 minus y, isn't it? Isn't it? ठीक छ, तर यहाँ y is equal to 1 हाल्दा फेरि यो अनडिफाइन आउँदै थियो. यहाँ y is equal to 1 हाल्दा के आउँदै थियो? अनडिफाइन आउँदै थियो. त यो y is equal to 1 हामी यहाँ लिनु सक्दैनौँ because 1 minus 1 is 0, that is x is undefined आयो. Undefined आउनु भएन. तर you can put y is equal to 0 out here. If you put y is equal to 0 out here, that is 0 upon 1 minus 0, that is your 0. Root over 0 is defined quantity. Okay. So what is the range? What is the range of this function? It is 0 less than y less than 1, and y should be equal to 0, but y should not be equal to 1. किनभने y is equal to 1 हाल्दा यो 1 minus 1 के आउँदैछ? 0 आउँदैछ, denominator 0 भने के हुन्छ? Undefined भइहाल्छ. Is that clear? So now write down what is the range of the function now. Therefore the range of the function, therefore the range of the function f is equal to what? Is equal to what? Y belongs to the set of real numbers. Y belongs to the set of real numbers, not all real numbers. Here the condition is y belongs to the set of real numbers, but y should lie between 0 less than y less than 1. 0 less than y less than 1, but y will be equal to 0. Y is equal to 0 हुन्छ अघि नै मैले भने यस्तो थियो नि, x is equal to root over y upon 1 minus y. So if you put y is equal to 0 here, 0 divided by 1, that is root over 0 is 0 defined. So you can put is equal to here. But if you put y is equal to 1, this is undefined quantity. So you cannot put is equal to 1 out here. Okay. So what is the range of the function f is equal to y belongs to the set of real numbers such that 0 less than or equal to y less than 1. So this is the range of the given function. So I think you have understood it. So you can copy it. Now we'll do the last part, that is your show that f is many one. Okay. So you have to prove that f is many one function now. So what is the given function out here? That is f of x is equal to x square upon 1 plus x square. So you have to show that f is many one function. Many one function means two elements. That is two or more than elements in the domain. Two or more elements in the domain have the same image in the codomain. That is your many one function, right? So if you put here f of 1, what is the value for f of 1 here? 1 whole square divided by 1 plus 1 whole square, which is equal to 1 upon 1 plus 1, which is equal to half, right? If you put f of minus 1, if you put x is equal to minus 1, what does it become? Minus 1 whole square divided by 1 plus minus 1 whole square is equal to 1 divided by 1 plus 1, which is also half. So in this case we see that, which implies therefore, or which implies that f of 1 is equal to f of minus 1, right? But in this case, is 1 is equal to minus 1? You 1 or minus 1 say equal huncha hudaina, but 1 is not equal to minus 1. So this example proves that f is many one function. So hence, kinabhane यहाँ दुईटा एलिमेन्ट्स को -1, 1 जुन चाहिँ डोमेनमा पर्दैछ यो -1, 1 यो 1, -1 जुन चाहिँ डोमेनमा पर्दैछ रियल नम्बरमा they have got the same image half comma half in the codomain real number, so it is many one function. Hence the function f is many one proved. So I think you have understood it, so you can copy it. Now we'll do the next question now. So now we'll do the next question. Yo अर्कै question हो तर important question हो. The question is, let A and B be two non-empty sets so that the function f, small f, such that this is the Cartesian product of two sets A cross B to B cross A, which is defined as the set of ordered pair. You know that Cartesian product is the set of ordered pairs, isn't it? F of within bracket A comma B is equal to B comma A is a bijective function. You have to prove that this function, which is defined as f of within bracket A comma B is equal to B comma A, is a bijective function. You know the meaning of bijective function, isn't it? The bijective function भनेको के हो? 1 1 पनि हुनु पर्यो, onto function पनि हुनु पर्यो. 1 1 function र onto function भएकोलाई चाहिँ हामी के भन्छौं? Bijective function. Okay? So now first of all you have to prove that this f is 1 1 function. Okay? Now for 1 1 function, for f to be 1 1, for f to be 1 1, right? So we have f of within bracket a1 comma b1 is equal to f of within bracket a2 comma b2. So if you can prove that a1 comma b1 is equal to within bracket a2 comma b2, then it is 1 1 function, right? So which implies that, so what is f of a comma b is equal to, it is defined as b comma a. So here you can write b1 comma a1, since it is given that f of within bracket a comma b is equal to b comma a, isn't it? So that's why what is f of a1 comma b1? It is b1 comma a1 within bracket is equal to what is here? This is b2 comma a2. Is that clear? So this set of ordered pair is equal to set of other ordered pairs. Set of this ordered pair is equal to set of other ordered pairs. Okay? Set of this ordered pair is equal to set of other ordered pairs, which implies that यसले के बुझाउँछ, यो first element equate गर्न सक्छ, or you can equate this second element is equal to second element. That means which implies that a1 is equal to a2 and b1 is equal to b2. I think you have understood it. So which implies that we can write here, यसलाई उल्टा बनाउन सक्छ अब तिमीले हैन, किनभने यो दुईटा इक्वल भयो नि त. तो यो a1 is equal to a2, b1 is equal to b2 भयो भने हामीले यसलाई के लेख्न सक्छौं, a1 b1, this is a1 b1 is equal to, this is your a2 b2. I think you have understood it. The f of a1 b1 is equal to f of a2 b2, it implies that a1 b1 is equal to within bracket a2 b2. So therefore f is 1 1. So we have proved that f is 1 1. About now you have to prove that f is onto function. For f to be onto, so let us assume that let us assume that this b comma a belongs to this b cross a, belongs to b cross a. Let small b comma small a belongs to b cross a So by definition of Cartesian product of two sets, what does it imply? That is, B belongs to the set B, B belongs to the set B, and A belongs to the set capital A, which implies that अब यो सेकेन्डलाई हामी फर्स्टमा लेख्न सक्छौं, यो फर्स्टलाई हामीले सेकेन्डमा लेख्न सक्छौं. A belongs to A and B belongs to the set B, which implies that now you can combine it with the help of Cartesian product of two sets. So A comma B belongs to A cross B. Is that clear? Now here what do we see? For each B comma A belongs to B cross A, there exists A comma B belongs to A cross B, such that f of A comma B is equal to B comma A. Is that clear? So now we see that for each B comma A belongs to B cross A, there exists A comma B belongs to A cross B, such that f of within bracket A comma B is equal to B comma A. Okay, so here we see that for each B comma A belongs to B cross A, there exists A comma B belongs to A cross B, such that f of A comma B is equal to B comma A. So therefore f is onto function. So therefore f is onto function. So we have proved that f is both 1 1 and onto function. So hence the given function f is 1 1 onto function. 1 1 onto function. So hence it is bijective. Hence it is bijective. Hence it is bijective proved. So is that understood now? So you can copy it. Now we'll do the next question now. So now we'll do the next question, that is, find the domain and range of the real function. You have to find out the domain and range of the defined function. Real function means defined function, that is f of x is equal to root over 9 minus x square. Domain means you have to find out those values of x for which f of x is defined. What is the range of the real function? Range of the real function means you have to find out those values of f of x for which x is defined. Okay, so let us find out the domain, that is the values of x for which f of x is defined. Okay, so now in this case, for f of x to be defined, we should have 9 minus x square should be greater than or equal to 0, isn't it? यो square root भित्रको यो जुन चाहिँ दिएको छ यहाँ variable, it should be 0. Root over 0 is 0 and it should be always positive. Square root of positive number is defined. That means for x to be defined, 9 minus x square should be greater than or equal to 0. Okay, so you can factorize it. 3 plus x into 3 minus x greater than or equal to 0. So suppose this is condition 1. Now we have to find out those real values of x for which this condition 1 is satisfied. Okay, you have to find out those real values of x for which this condition 1 is satisfied. Okay, so if you put x is equal to 3 and minus 3, this will be 0, isn't it? So if x is equal to 3 or minus 3, then condition 1 is satisfied. Then condition 1 is satisfied. Then condition 1 is satisfied. Okay. So now let us draw a number line here. So let us draw a number line now. So you can mark these 2 points, x is equal to 3 and x is equal to minus 3. Suppose this is x is equal to 3. So where does it lie? X is equal to minus 3. It lies on the left of x is equal to 3. This is x is equal to minus 3, right? So this is your x greater than 3, right? This is x greater than 3 and this one is x less than minus 3. And in between this minus 3 and 3, what do we have? Minus 3 less than x less than 3. So I think you have understood it. Okay. Now here x greater than 3. If x is greater than 3, you have to check whether it is greater than 0 or not, whether condition 1 is satisfied or not. If minus 3 less than x less than 3, you have to check whether condition 1 is satisfied or not. If x is less than minus 3, you have to check whether this condition 1 is satisfied or not. Okay. So now let's check it. So if x is greater than 3, if x is greater than 3, if x is greater than 3, what can you say about 3 plus x? Is it positive or negative? This 3 plus x is positive. This 3 plus x is positive. Okay. This 3 plus x is what? Positive. And what's about 3 minus x? If x is greater than 3, if x is greater than 3, 3 minus x, whether it is positive or negative. If x is greater than 3, it is negative. Negative. It is negative, isn't it? So positive and negative is negative. Positive and negative is negative. So this is your negative. If x is greater than 3, then the product of this two expression is negative. But we should get positive here. Okay. So if you have minus 3 less than x less than 3. If x is greater than minus 3 but less than 3. What can we say about 3 plus x? Is it positive or negative? You can put 0 here. X is equal to 0. 3 plus 0 is positive. So it is positive. It is positive. Okay. Again, what's about 3 minus x? X is less than 3. So 3 minus x is positive. You can put 0 here. It is also positive. So positive into positive is positive. So this is your positive quantity. This is your positive quantity. Okay. Next, if x is less than minus 3. If x is less than minus 3, what can you say about 3 plus x? Is it positive or negative? X is less than minus 3. Minus 4. So 3 x was minus 4 alda minus 1. That is your negative. This is your negative. Negative into, if x is less than minus 3, what can you say about 3 minus x? Is it positive or negative? X less than minus 3 minus 4 ala. Minus to minus plus. 3 plus 4 is 7. That is your positive. So it is positive. Positive and negative is negative. So this one is your negative. The condition 1 ma positive के मा हुँदैछ यो minus 3 less than x less than 3. Okay. So this condition 1 is satisfied if minus 3 less than x less than 3. So the condition 1 is satisfied if what? If this one you positive and the you दुईटा त नेगेटिभ आउँदैछ तर condition on the positive sir. That means if minus 3 less than x less than 3 तो यहाँ is equal to 0 पनि छ भनेपछि x is equal to 3 र x is equal to minus 3 हाल्दा 0 हुँदैछ भनेपछि यहाँ हामी के लाउन सक्छौं is equal to लाउन सक्छौं. So this is the domain. What is the domain of the function? The domain of the function is minus 3 less than or equal to x less than or equal to 3. So you can write here, therefore the domain of the function is, therefore the domain of the function, therefore the domain of the function is, what is the answer? It is minus 3 less than or equal to x less than or equal to 3. तो यति भ्यालुजमा x को -3 to 3 यति भ्यालुजमा मात्रै यो f of x के हुन्छ डिफाइन हुन्छ. That means what is the domain of the function? The domain of the function is -3 less than or equal to x less than or equal to 3. So you can copy it. Now we will find out the range of the function. So I already told you that. So how can you find out the range of the function, isn't it? You have to find out, you have to write let y is equal to f of x root over 9 minus x square. Now you have to find out those set of values of y or f of x for which x is defined. Okay, so now let us find out the range like this. Okay, so let y is equal to root over 9 minus x square. Okay, so let us express x in terms of y. Squaring both the sides, what do we get? Y square is equal to 9 minus x square. Okay, or x square, take it to the left hand side. So x square is equal to 9 minus y square. Or what is the value for x? X is equal to root over 9 minus y. So you may write plus minus also. It doesn't matter, right? So this is your x is equal to root over. Now it is root over. This is 3 plus y into 3 minus y. I think you have understood it. Now we have to find out those set of values of y for which x is defined. You have to find out those set of values of y for which x is defined. Okay, for x to be defined, that is the expression within a square root should be greater than or equal to 0, because the square root of 0 is defined and square root of positive number is also defined. Okay, so for x to be defined, we have 3 plus y, 3 minus y should be greater than or equal to 0, right? So let us do it now. Let us find out the values of y for which condition 1 is satisfied. Okay, so this is condition 1. This is condition 1. Okay, now first of all you have to check for which value of y this left hand side exactly equal to 0, because it is equal to 0 is also given, isn't it? So if y is equal to 3 or minus 3, then this left hand side is 0, isn't it? Then condition 1 is satisfied, because if you put y is equal to 3 or y is equal to minus 3, this left hand side is equal to 0, is equal to is also there, that is equal to 0. So condition 1 is satisfied. So condition 1 is satisfied. Okay, now let us draw the number line here now again. Similarly, as in domain, you can solve for range also. Okay, so this is your number line. So this is y is equal to 3. Exactly this point is y is equal to 3, and exactly this point is what? Y is equal to minus 3. So on the right of y is equal to 3, you may have y greater than 3. On the left of y is equal to minus 3, you may have y less than minus 3. And in between these two values, minus 3 less than y less than 3. Minus 3 less than y less than 3. Okay. Now, so now for y greater than 3, is condition 1 satisfied or not? You have to check it. For minus 3 less than y less than 3, whether condition 1 is satisfied or not, you have to check it. For y less than minus 3, whether condition 1 is satisfied or not, you have to check it. Okay. So now, if y greater than 3, so let us check for y greater than 3, whether condition 1 is satisfied or not. If y is greater than 3, what can you say about 3 plus y? It is positive. What's about 3 minus y? It is negative. So positive and negative is negative. You के आउँदैछ हाम्रो negative आउँदैछ. I think you have understood it. If y is greater than 3, 3 plus y is positive. This is positive. But 3 minus y is, if y is greater than 3, 3 minus y is negative. So positive and negative is negative. Condition 1 is not satisfied. Okay. For y lies within minus 3 and 3, that means you can put 0 to check it. So if y lies within minus 3 and 3, what's about 3 plus y? Is it positive or negative? You can put y is equal to 0. It is positive. This is your positive, right? This is your positive y. 3 minus y. You can put 0 here. 3 minus 0 is 3. That is your also positive. So positive into positive is positive. So this is your positive quantity, right? Next, if y less than minus 3, if y less than minus 3 means minus 4. So what can you say about 3 plus y? Is it positive or negative? Negative. This is your negative. You can put minus 4 here. 3 minus 4 is minus 1. What's about 3 minus y? You can put y is equal to minus 4. Minus 0 minus plus 4. 3 plus 4 is 7. That is your positive. So positive and negative is negative. So this is your negative. Is that clear? But it should be positive. It should be what? Positive, isn't it? Greater than 0 sir. Kun chayma greater than? Positive kun chayma यसमा. But it's your condition bhayego. So therefore the condition 1 is satisfied. Therefore the condition 1 is satisfied. The condition 1 is satisfied if minus 3 less than y less than 3. But in this case, your condition 1 is equal to 0 पनि छ. Is equal to 0 चाहिँ कति बेला हुन्छ? If you put y is equal to exactly 3 and y exactly equal to minus 3. Y is equal to 3 हाल्ने बित्तिकै यो 0 भयो. Y is equal to minus 3 हाल्ने बित्तिकै यो पनि 0 हुन्छ. भनेपछि हामी के लेख्न सक्छौं? यो is equal to लेख्न सक्छौं. So what is the range of the function now? Therefore, the range of the function is this one. Therefore, the range of the function is you can write it as y belongs to real number such that minus 3 less than or equal to y less than or equal to 3. This is the answer. Your domain पनि हामीले यसै लेख्दा पनि हुन्छ. X belongs to the set of real numbers such that minus 3 less than or equal to x less than or equal to 3. Okay? You can write it like this also. The domain of the function is x belongs to the set of real numbers such that minus 3 less than or equal to x less than or equal to 3. This is the answer for domain. This is the answer for range. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question. That is this question is also very, very important. You have to find out the domain and range of the real function defined by f of x is equal to 1 upon 1 minus x squared. Here x belongs to the set of real numbers. You have to find out those values of x for which f of x is defined. Okay, you have to find out those set of values of x for which f of x is defined, and also you have to find out those in order to find out the domain, you have to find out those values of x for which f of x is defined. Okay, in order to find out the range of the function, you have to find out those values of f of x for which x is defined. Okay, so now here given is f of x is equal to 1 upon 1 minus x square. So in this case, it depends upon the values of x for which f of x is defined or undefined. तो यहाँ हामी के देख्दैछौं 1 minus x square चाहिँ डिनोमिनेटर मा छ. यदि यो डिनोमिनेटर नै 0 भन्दा f of x undefined हो, त if f of x is undefined, then 1 minus x square should be equal to 0, isn't it? So if 1 minus x square is equal to 0, then f of x is undefined. That means 1 minus x square is equal to 0 हुनु भएन. यहाँबाट x को भ्यालु निकालौं. कति आउँछ हेरौं. That means x square is equal to 1 or x is equal to plus minus 1. So if you put here x is equal to 1, it will be undefined quantity. If you put x is equal to minus 1, it will be undefined quantity. भनेपछि यो डोमेन भएन. x is equal to plus minus 1 चाहिँ यहाँ हुनु भएन, तर except x is equal to 1 or minus 1 अरु भ्यालुजहरु हाल्यो भने चाहिँ यो के हुन्छ, डिफाइन हुन्छ. That means what is the domain of f of x? It is the set of real values of x except x is equal to 1 and x is equal to minus 1. So, हामी कसरी लेख्छौं यसलाई? So, domain of the function is equal to set of real numbers, all those set of real numbers, but त्यो set of real numbers मा plus 1 र minus 1 चाहिँ हुनु भएन. That is minus लेख्न त्यही यसरी लेख्नु minus 1 1. That means x is equal to minus 1 or x is equal to 1 should be excluded in order to have the defined f of x. The x is equal to minus 1 or 1 चाहिँ हुनु भएन त्यो set of real numbers मा for f of x to be defined. So I think you have understood it. So what is the answer for the domain of the function? Domain of the function is equal to set of real numbers minus x is equal to minus 1 or x is equal to 1 चाहिँ हुनु हुँदैन भनेको. Is that clear to all of you? So I think you have understood it. So this is the answer for the first part, that is your domain. Now let us find out the range of the real function. What is meant by range of the real function? Those set of values of the function f of x for which x is defined. So let us assume y is equal to f of x. So let y is equal to f of x is equal to 1 upon 1 minus x square, right? So which implies that y is equal to 1 upon 1 minus x square. Now let us express x in terms of y. So below y there is 1. Let us cross multiply it, or 1 is equal to 1 minus x square y, right? So let us get the value for x square, or this is x square y is equal to y minus 1, or x square is equal to y minus 1 upon y, or what is the value for x here? It is root over, you can separate the term 1 minus 1 by y. So I think you have understood it. So this is square root of a number. For x to be defined, it should be square root of positive number including 0. For x to be defined, the expression within square root should be 0 or more than 0, or it should be positive. So here you write, for x to be defined, 1 minus 1 upon y should be greater than or equal to 0. Is that clear? So, or 1 minus 1 upon y, this 1, take it to the right hand side, minus 1 upon y greater than or equal to minus 1. Okay, so if you change this minus into positive, this greater than becomes less than. You know that, isn't it? Suppose you have minus 3 is less than, minus 3 is less than minus 2. You know that, isn't it? Minus 3 is less than minus 2, right? So if you change this minus sign into positive sign, it will be 3, and this less than becomes greater than 2. 3 is greater than 2. Okay, similarly if you change this minus to positive, it will be 1 by y less than or equal to 1. And if you invert both the sides, this less than becomes greater than. Is that clear? So similarly, if we have, you know that 10 is greater than 5. So if you invert both the sides, this greater than becomes less than. So which implies that 1 upon 10, 1 upon 5. This greater than becomes less than. That is 1 by 5 is more than 1 by 10. It is obvious, isn't it? So here also, if you change, or if you invert both the sides, this less than becomes greater than. So 1 upon y is y. This less than or equal to becomes greater than or equal to 1 upon 1 means 1. So y is greater than or equal to 1. So what is the range of the function? It is y greater than or equal to 1. So write down, therefore the range of the function is, therefore the range of the function is equal to, range of the function is equal to, within second bracket, y belongs to the set of real numbers such that y should be greater than or equal to 1. So this is the answer. So what is the range of the given function? Y belongs to the set of real numbers, but y should be greater than or equal to 1 always. Is that clear? So this is the answer. So I think you have understood all the problems that we did today. त तिमीले यो घरमा रिभिजन गर राम्रोसँग त नेक्स्ट क्लासमा म अझै यस्तो टाइपको प्रब्लमहरु अझै गराउँछु बुझ्यौ त घरमा तिमीले रिभिजन चाहिँ गर्नुपर्छ ठीक छ सो दिस मच इज फर टुडे